Welcome to our lesson on trigonometric ratios. Trigonometric ratios. Now, when we're talking about trigonometric ratios, is we're talking about the ratios of the sides of a right angle triangle. Trigonometric ratios are the ratios of the sides of a right angle triangle. Now, we have to talk about three terms before we get into these ratios. Our first term, as we know from the last class, is our hypotenuse. And we said the hypotenuse is the longest side in our right angle triangle. And that side is opposite the right angle. Side is opposite the right angle. Now, we want to talk about two other terms, the opposite and the adjacent. The opposite and the adjacent. Now, in a right angle triangle, when we're talking about the opposite and adjacent, we talk about it in relation to an angle. In relation to an angle. So, we first must observe which angle we're talking about and then identify the opposite and the adjacent based on that angle. So, if we're speaking about angle A, the opposite will be the side directly opposite the angle. So, the opposite is the side opposite the angle that we would have identified. And the adjacent is the side that runs along the angle that we would have identified. So the opposite in this case will be this side over here. The adjacent will be here. Now, the trig ratios say that, and the three trig ratios we will talk about that are commonly used would be sine, cosine, and the tangent. Sine, cosine, and tangent. And in relation to angle A, sine is equal to the opposite over the hypotenuse. The opposite over the hypotenuse. Cos A is equal to the adjacent over the hypotenuse. And tan A is equal to the opposite over the adjacent. Now, what for this lesson, please ensure you have your calculators with you. Now, what it is we're talking about when we're talking about the ratios. Now, if we're given this angle here, if we in our calculators we sine that angle, we press sine, or according to how your calculator operates. Some calculators you have to put the angle first, then press sine. Other calculators you have to press the sine, then the angle. So what it is saying, if we have an angle and we sine that angle, it will be equal to the same answer if we divide the length of the opposite. The length of the opposite divided by the hypotenuse, we will get the same answer. If we cos an angle and divide the adjacent and the hypotenuse, the two answers will correspond. And if we do the same for tan, if we tan the angle and we divide the opposite by the adjacent, the two values will be the same. Right? Now, there are various ways persons will do to remember these ratios. Now, sine is equal opposite over hypotenuse. Cos is equal adjacent over hypotenuse. Tan is equal to opposite over adjacent. Now, some persons would say, to remember it, some old horses can always hear their owner's approach. Some old horses can always hear their owner's approach. Or some persons write it as a word. I hope we can pronounce this word. And what they say is sokatoa. Sokatoa. Some old horses can always hear their owner's approach. Or SOHCAHTOA. Which one is easier for you, you can use that. But I could remember from since my high school days, I remember it using some old horses can always hear their owner's approach. Or if you are brave enough, SOHCAHTOA. Now, let us do an exercise where we will write the trig ratios in terms of x, y, and z. X, y, and z. So we want to find what is sine B, cos B, and tan B. And we want to write it in terms of x, y, and z. Now, the first thing we need to do is identify what is the opposite and the adjacent. We identify the opposite and the adjacent angles. Now, if this is our angle we're talking about, the opposite of that angle will be here. This will be the opposite. X here will be the adjacent, and this side will be our hypotenuse. So sine B, remember sine B is equal to the opposite over the adjacent. Sine is equal to the opposite over the adjacent. So what is the opposite here? Sorry, sine is equal to the opposite over the hypotenuse. Opposite over the hypotenuse. So sine B is the opposite over the hypotenuse. Which letter represents the opposite? Y. So y over z, that will be sine B. Cos B will be the adjacent over the hypotenuse. The adjacent over the hypotenuse. So cos B is the adjacent, runs alongside, so that will be x over z. And tan B will be equal to the opposite over the adjacent. The opposite over the adjacent. Which will be equal, the opposite of B will be y, the opposite over the adjacent x. And there we have sine B in terms of x, y, and z. Now, in our next class, we will start working to find the angles or the length using our trig ratios.